Hi, sixth graders. This video is on writing expressions and equations. So make sure you have your notes template either printed out or in the packet, or you've uploaded to Notability so that you can split screen this video with your notes just like you've been doing in the past. Our learning target is being able to write verbal phrases and sentences as simple algebraic expressions and equations. So before we can write expressions and equations, we need to make sure we understand different words and how they represent different operations. So I'm going to give you some words that I want you to fill in the table for each operation. But before I start, I want you to see if you can come up with at least one word, maybe two per operation, and write it down that represents that operation in a word instead of by the symbol. So for addition, some examples of some words that mean addition could be more than, sum, which is the answer to an addition problem, plus, increased, because increased means that it is getting higher and we're adding everything together, and then total also just means the total of everything. For subtraction, we could have subtracted from, we could have minus. So a couple of them are kind of just straightforward, telling us, you know, a number is subtracted from t or something like that. Less than, decreased, which is the opposite of increased. Decrease means that it's getting lower or we're taking away. And then difference. So the difference is the answer to a subtraction problem. And then we have less. Less and less than are different when it comes to representing a subtraction problem. So that is something that we need to look closely at, and we'll look at that when we have expression and equations later in this video. And then we have multiplication. So it just could simply be something multiplied by something else. Times means multiplication. Product means multiplication. That's the answer to a multiplication problem. And then twice or twice as much would mean to multiply it times 2. And then lastly, for division, it could just say something divided by something else. It could say the quotient of something and something else. The quotient is the answer to a division problem. It could just simply say divide this by this, or half also would mean divided by 2. Okay, so let's try some expressions together. Remember, expressions do not have an equal sign. So an expression is numbers, variables, and an operation, but it doesn't necessarily equal anything, meaning we can put whatever we want into those variables and it will still work out because it's an expression. So let's look here. We have 3 times Drake's age D increased by 3. So 3 times Drake's age D goes together. Times tells me that it's multiplication, and then increased by 3 tells me that it's addition. So 3 times Drake's age D, I'm going to write it as 3D, because a number next to a variable means multiplication. And then we increase it by 3, so it would be plus 3. So whatever I'm told Drake's age is, I'm going to then be able to multiply that times 3 and add 3 to get my solution. But right now, I don't know what Drake's age is, so then we just leave it as 3D plus 3, since it's an expression. The quotient of a number x and 5 increased by 5. So we have the quotient of a number x and 5 go together, because we're finding the quotient of those two together, and then afterwards we increase it by 5. So quotient, remember, means division, so I'm going to write it as x divided by 5. There's different ways that you could write it, but x divided by 5, then I increase it by 5. So it'd be x over 5 plus 5. And again, I leave it like that until I'm told what x is, and then I put it in, and then I would be able to make it into an equation and see what it equals based on the value of x. Then we have 10 less than the product of 16 and a number x. So we're taking the product of 16 and a number x. So those have to go together and stick together. And product, we know means multiplication. And then 10 less than is subtracting from that product. So first I'm going to create this part of my expression with the product of 16 and x. And I'm going to write it as 16x. And I kind of can think of it as order of operations. Multiplication comes first, then subtraction. So that's how I'm going to write my expression. So 16x, then it's 10 less than that, which means that I'm subtracting 10 from that. Even though 10 is before, so it doesn't necessarily mean 10 minus that, I'm taking it away from it, so it needs to be 16x minus 10. You pause the video and try these two, and then come back and check your work. So we have twice a number x increased by 5. So twice a number, twice meaning 2, and that means 2 times. So it'd be 2 times x. Again, I'm just going to write 2x, meaning 2, and then this x is what I'm including in here because a number next to a variable automatically means multiplication. So 2x and then increased by 5 would be plus 5. Sarah's age x decreased by 1, which I know is subtraction. So x minus 1.
Okay, now we're going to be looking at equations. Again, equations have the equal sign. Anytime that we see something like this, is 20, that word is, that's in place of the equal. So just know that that's what our equation is going to be equal to. So 2 times Lizzie's age, A, increased by 8, is 20. So I'm going to take this and I'm going to kind of break it apart. So I have 2 times Lizzie's age, A, well, times tells me it's multiplication. Increased by 8, increased meaning addition. So I'm going to take Lizzie's age, which we're using the letter A, and we're multiplying it by 2. Again, a number and letter together means multiplication. Now increased by 8 is 20, so that means it's going to be equal to 20. The thing with the equations then, the variable can only be worth one value, unlike expressions. Next one, the quotient of a number x and 4 increased by 5 is 12. So again, I'm going to break this apart. So the quotient of a number, the unknown x and 4, so that means we're taking x divided by 4, increased by 5, well, increased meaning addition, is 12. And that is the equal, so equals 12. The next one, 8 less than the product of 6 and a number is 32. First thing I noticed, they don't tell us a variable on this one, so we can decide what we want the variable to be. Anytime that we have something like this, 8 less than, it has to be written as the other part minus 8. Addition, we could write it in any order. Multiplication, we could do it in any order. But subtraction, it would have to, in this case, come after the rest of it. So 8 less than, that means we're subtracting 8. Product of 6 and a number is 32. So product meaning multiplication, so I'm going to just use the letter Y. 8 less than, so that means we're subtracting 8 from that. And that is 32, so that equals 32. Okay, a couple for you to try. Pause and try them on your own. Twice a number increased by 7 is equal to 27. This time they tell us it's equal, but that isn't always in the number. Twice a number means multiplication. Increased by 7, looks like we're adding, and then it's going to be equal to 27. Again, they don't tell us the variable, so we could pick any number. So W, twice a number means 2 times that number. Increased by 7 is equal to 27. Just writing it in math form. Again, these algebraic equations have to have a number and a letter. and at least one operation, and then the equal sign on there. Last one, Tom's age X less than Joan's age of 89 is 45. Again, this less than means that we're going to be subtracting Tom's age from Joan's age. Well, Joan is 89, so we would take that 89 and we would subtract off Tom's age, and that is 45, so that equals 45. Okay, a few more to try. Feel free to pause and try them on your own. 9 less than the product of 15 and a number is 3. So I see that is 3, so I know this one is going to be an equation because it'll have an equal sign. Again, 9 less than means we are subtracting 9 from the product of 15 and a number. So it doesn't tell me the variable, so I can pick anything, 15x. 9 less than, so we're subtracting 9, is 3. So it's going to be equal to 3. A number x less than the quotient of 24 and 2 is 1. So again, we have that is 1, so that means it's going to be an equation. Less than tells me we are subtracting off x, and quotient means we are going to be dividing. So we're going to take 24 divided by 2, x less than, so subtracting x, and that is equal to 1. Last one, Pam had 17 coins. Then she found P more coins in a drawer. We don't have an answer on this one, so this is going to be an expression. So we're going to take her 17 coins. P more tells me that we're adding. So then we're going to add on the coins that she found. And we would just leave it like that. Okay, so now we're going to be writing equations when giving a word problem, and really just more focusing on choosing a letter to replace an unknown quantity is called defining the variable. So when we are given word problems, we have to figure out what it is that we don't know, and that's what our variable will be. So when we are writing equations with word problems, first, again, define the variable. Figure out what it is that we're looking for, what we don't know. Then we're going to write the equation to represent that situation. And then you would be able to solve for the variable because, again, equations only have one possible answer for the equation. So here's our examples. John has 16 video games. This is 5 less than Chelsea has. How many video games does Chelsea have? So first thing, I'm going to define the variable. Well, that question, how many video games does Chelsea have? That's what we're looking for. So I'm going to use C for Chelsea's games. That's what we're trying to find. So John has 16, so we know how many he has. Chelsea has 5 less than him. So, John has 5 less than Chelsea. So I'm going to take however many Chelsea has, we don't know, and we're going to subtract off the 5, and that's going to equal how many games John has, and he has 16. And then we could solve this equation to figure out how many games Chelsea has. The next one, Aaron buys a movie, popcorn, and a soda for a total cost of $6.25. That seems important. What is the cost of the popcorn? Okay, that's what we're trying to find. If the movie and soda cost $4.70 together. First thing, define the variable. Well, we are trying to find the cost of the popcorn. So P for cost of popcorn. Now it's telling us that it was a total of $6.25. That total tells me that's the answer. So I'm going to have this set equal to $6.25. So there was the $4.70 for the movie and the soda, plus however much the popcorn was. That's what we don't know. So that's what we're adding on to equal that $6.25. So again, define the variable, write the equation, and then in the future we'll learn how to solve. Okay, that's all for the video. You have some practice to do. Use these notes as you are practicing. 2 skills you need to complete on iExcel, 6Z3 and 6Y3, both to a score of 50+.